Hello, welcome to this episode of creating a linear algebra library in C++. So we've been working on this matrix class for a while, and currently we are initializing the matrix data to values of ones. In performing any kind of computation, our matrix data will not necessarily be values of ones. It could be that our data is stored in a certain file, and hence we will need to read the data into the program and then convert this data into a matrix. So in this video, we are going to add an implementation to read data from files. To do this, I'm going to right-click on our source folder and create a new class. I am going to name the class reader. We have our reader.cpp and reader.h files created outside our source folder, so I'm going to select both files and drag them into the source folder. You may be wondering why we need to create a class in order to put in a logic to read data from files. We could of course put the logic for reading data from files into our matrix class. But then if we do that, we will be violating the purpose of object-oriented programming. Because in object-oriented programming, each class is supposed to have a specific function. So just like we have a matrix class which holds the logic for our matrices, we should have a separate class that is going to be only responsible for reading and writing data. To read data from files, we need to include the fstream library. This library is going to enable us to open data files and also access the data that is present within the data file. When reading data from file, we need to store some specific information. For example, I've added this batch.csv file, and if I open the batch.csv file, we can see that the data has some columns with some column names, and it also has some rows which contains the data itself. We also see that the data has some number of columns and also number of rows. And this is the data that we intend to store within our reader class. So I have created three variables, one to hold the number of rows, one to hold the number of columns, and the third variable to hold the column names that are present within the data file. For us to be able to create vectors and strings within this reader class, we will need to include the string and vector libraries. Now let's create a function that is going to return this information from the file and store them into these variables that we have created. I have created a function which I'm naming as getFileInfo. We are going to keep this function as public for now. This function takes in a couple of arguments. First, it takes in a string pointing to the location of the file that we would like to read into the program. It also takes in a Boolean parameter which I have named as header. And this Boolean parameter is going to specify whether there are column names present within our data file. So for instance, in our batch file, there are column names present, that is X and Y. So the Boolean parameter will have to be set to true. There is also a character parameter that needs to be specified within this function. We are defaulting this character parameter to comma because in most cases you will be working with comma delimited files. But we are not only limited to comma delimited files. This delimit can be changed to suit the type of data file that we are working with. Let's create the function implementation. In the reader.cpp file, where we are implementing the getFileInfo function, I'm creating an instance of an fstream class that is present in the fstream library. I'm naming this instance FileOpener. This class has functions that enable us to communicate with files that are located on our disk. To open the file that is located on our disk, we will need to call the open function from this class and pass in the file path that is pointing to the location of the file that we would like to read. And now once the file opener opens the file path, we would like to check whether indeed it was able to find the file that we want it to open. If that is so, we would like to read the first line within the file and print it on the console. To do this, we will need to call this getLine function from the standard library and pass in the open file that we would like to read the lines from. After reading the particular line within the file, we would like to display the red line on the console. For us to be able to print messages onto the console, we will need to include the iostream library. So let's include the library in the reader.h file. And once we are done printing out the desired line that we would like to print, we will close the file. Let's go to our main.cpp and run this program. In the main.cpp, I've added the reader header file so that we can utilize the reader class. I've also added a string library to store the path to the data file that we would like to read into this program. I am then passing in the data path into the getFileInfo function that we just created, and specifying that there are indeed headers present within the file. Let's run this program and see what gets displayed on the console. And indeed, we have our column names displayed on the console, but that is not exactly what we want yet. We would like to find the number of rows, number of columns, and also store the column names that are present within the file. So let's go back to our reader.cpp file. So when we call the getLine function, it just got the first line, printed it on the console, and then we close the file. So let's see what will happen if we call the getLine function repeatedly and print out the red line. So I've created a while loop that is going to call the getLine function repeatedly. It is going to read a particular line and then print it out on the console. Let's run this program again and see what happens. And now we are not getting only the column names that are present in our file printed on the console. We are also getting the entire data that is present in our file printed on the console. So what is happening? Whenever the getLine function is called, a row within our data file is read. So when the getLine function was called in the first instance, the columns were read. And the second time that it was called, it jumped onto the next row and it read the next row. This routine will continue until it gets to the end of line. And when it gets to the end of line where there is no data read, the loop breaks. Which means if we call this getLine function repeatedly, we can get the number of rows that are present within our data file. So now we are going to add an integer variable that is going to keep track of the number of rows that are present within our data file. Because we will only like to count the number of data rows that are present in our data file, and we would like to exclude the column names. If there are headers present within our data file, we are going to set the row count to -1, otherwise we will initialize the row count to 0. And now whenever we call the getLine, we are going to increment the row count. So by the time the getLine function gets to the end of our data file, we would have known the number of rows that are present in our data file, and hence we can store the number of rows into the end rows variable that we created. But that is not all that we are looking out for. We would also like to count the number of columns. So let's see how we will be able to count the number of columns. And to do that, we will add a new function which we are going to name as getColumnInfo. In implementing the getColumnInfo function, like we were able to look through our data file one after the other and get count of the rows, we want to do something similar like that to get count of the columns. For us to be able to do that, we need to convert the red line into a string stream. Once we are able to convert the red line into a string stream, we can apply the getLine function to count the number of columns that are present within the data file. So let's see how we can do it. First, we need to create this string stream instance, which I'm going to call line2stream. For us to be able to utilize this particular class, we will need to include the string stream library in the reader.h file. And once we have converted our red line into string stream, we can apply the getLine function to read individual columns that are present within our data file. And just like we did for the number of rows that are present within our file, we can repeat a similar thing. We call the getLine function and pass in the string stream, and whenever the getLine function reads a particular string, we will store that red string into the column name, which is a variable we are defining up here. And then we are setting an extra parameter, that is the delimit. And what we want to tell this getLine function is to read a chunk of string up to this character. So whenever you read up to this character, you need to stop and return us whatever that you have read. So for instance, if I open our batch file, in the beginning, the getLine function will read this particular X, and when it gets to the comma, it returns this X string. And then once it returns this X string, we are going to store this X string into our columns variable that we created. The getLine function will then be called again, and it's going to read this Y string and then return it. And once it returns the Y string, we will store the Y string into our columns variable. Since there is nothing to read after Y, we can now set the n columns variable to the columns.size. This size function is a function that is present within the vector class, and this function returns the total number of elements that are present within an instance of a vector. So this will be equal to the number of columns that we will like to get from the file. And now all we need to do is to call the getColumnInfo in the getFileInfo function, and that is what we are doing here. But now the problem is we would not like to run the getColumnInfo function multiple times, because if we do that, that means the column names that is already saved will be overwritten. And hence, to resolve this, let's first create a Boolean parameter. We will first initialize the Boolean parameter to false. So in the first instance, when the getLine function is called, the Boolean parameter will be false, and hence the getColumnInfo function will be called. And then we will be able to save the column numbers and also the column names. Then once we do this, we are going to set the saved columns Boolean parameter to true. And hence, when the getLine function is called once again, this parameter will be true, and hence this function will not be run again. So with this, we have been able to get the information about our files regarding the column numbers, the row numbers, and also the column names that are present within the file. What we need to do next is to read the data itself from the file. We have to go through this trouble first because we need the dimensions of the data that is present within our file. And as we did for our matrix class, we are going to represent our data by a one-dimensional array. And like you know from previous tutorials, to create an array, we will need to know the exact size of the array before we can create the array. And that is why we needed to know the number of rows and the number of columns that are present within the file. So let's create a variable to hold the data that is present within our file. In the getFileInfo function, after we have known the number of rows and number of columns, we would like to allocate space to hold the data that is present in our file. And now with the space allocated for our data, we can now fill our data with the data itself that is present in the file. And as you could imagine, we are going to repeat a similar thing for what we did for getting the dimensions and the column names in the file. So let's implement getting the data and filling it into our variable that we just created. First, we need to keep track of the data count that is present within our file, because that is what we are going to use to index our file data array that we've created. Whenever we read in the data, we are going to increment the data count variable. We also need a string variable to hold the string that is going to be returned from the data file. Even though we have doubles, but once we are reading from files, it will be interpreted as strings. So here, what we want to do is we only want to start saving data into our file data variable or our file data array when we know that we are not reading in the column names. And to check this, we will check whether the row count variable is greater than or equal to 0, which means that if we are resetting this row count variable, we should repeat a similar thing like we did here. So whenever the row count variable is greater than or equal to 0, we know that we have passed the column names and we need to start saving the data itself. Like we did for storing the column names that are present within the data file. What the getLine return is lines, so we need to convert these lines into a file stream to be able to read each individual chunk of strings like we did for the getColumns function. The getLine function will go through this file stream, read a chunk of string till it gets to this delimit character, and then it returns this string into the column name. So it's similar thing that we are going to do. Let's copy this while loop here. The getLine function will return 1 as a string. We will need to store this data string in our file data array. To do this, we will first need to convert this from string to double. We already have this variable here that is going to keep track of the number of data that is present within our data file. With this data count, we index our file data array. We convert this string into a double. Once we convert it into a double, we store this double into our file data array and then increment the data count. And if you look at how the data is going to be arranged, it is the same as what we are doing for our matrix class. We have the first row being the first element of the array, followed by the next row, and so on. Let's increment the row count whenever the getLine function is called. When this while loop runs, it runs until it gets to the end of the file. So at this point, the cursor is still at the end of the file. So if we try to run this loop again, it will just break on the first call because the cursor will already be at the end of the file and there will be nothing to read. One option that we can do is we can utilize a function that is called seek, so that we seek to the beginning of the file. We can also simply close the file before and then reopen the file. And with this, we'll be able to get information about the data that is present within our file, store the data in an array, and also get specific information about the file. So let's implement a custom function that is going to print the data that is present within the file on the console. So I've added a new function of a void return type, which I've named it as head. This function is going to print the data that is present within our file. So let's see how we are going to implement this function. To print the data on the console, we first need to print the column names on the console. So we create a for loop that loops through all the column names and print it on the console. We also want to format the printout on the console such that each printout has the same width. And to do this, we are calling this function to set the print width of the console to 10. This function is defined in a library which we will also have to add to our reader.h file. So let's add it. So now let's print the data itself on the console. We are going to repeat a similar thing like we did for the columns, just that now we will need to loop through the rows and print out each column data as well. So we create a for loop that goes through all the rows that are present within the file. And for each of the rows, we are going to go through all the columns. And as you remember from the tutorial on the matrix class, we can calculate the index of the element within our array. And once we have that particular index, we are going to print it on the console and then set the width, the print width to 10, just like we did above here. So let's test this out and see. So after we've read in the file using the getFileInfo function, we are going to call the head function for it to print the data on the console. So let's build and run our program and see the results. As you can see, the data has been printed neatly on the console. I think that is going to do it for this video. In the next video, we are going to expand on this reader class. We are going to expand on it in such a way that the user can pass an integer into the head function such that just a specific number of rows within the file can be printed on the console. Because if you have large data files, it will not be optimal to display all the data on the console. So we will add that functionality in the next video. We will also give the functionality in which the user can skip some rows that are present in the file. Because usually the data files might come with some not important data rows which we would like to skip. So for instance, if there are some kind of gibberish, Here we would like to give the functionality to skip these tables. We will also add the functionality in which the user can skip multiple rows within the file. So as you can see, there are a lot of interesting stuff packed within this series, and I will encourage you to subscribe, like, and share this video. With this, I thank you for your attention, and I will see you in the next video. Bye.